Hey guys. All right. So we are answering the question today of how do you know if are a poor EFA converter, which means a poor converter of essential fatty acids, specifically a poor converter of the forms of essential fatty acids found in plant oils to the ones that we actually need in our bodies. Um, and this is based on a question from Juliet, who commented in the Vitamins and Minerals 101 premium forum, which is available to um, people who Vitamins and Minerals 101 premium is a gift right now to people who pre-order the Vitamins and Minerals 101 book. And there's a section on omega 6 in the chapter on omega 6 fatty acids. There's a section about how vegans or people who do not eat liver and egg yolks can use arachidonic acid supplements from if you go on Amazon, you'll see, if you just search arachidonic acid, you'll see like X Factor and some other ones. They're generally geared at bodybuilders, actually. But they have arachidonic acid that is derived from the fungus Mortariella alpina. And it is, arachidonic acid is usually found in animal foods, but this is from a mushroom. And so I presume it's vegan, but I generally advise that people who have, strict ethical standards along the lines of veganism should inquire with the manufacturer to see if in the background the manufacturing process actually meets their standards, because I'm not sure exactly how it's produced. But anyway, the idea here is that some people, my basic position on this is consuming arachidonic acid and DHA, the omega-3 fatty acid in foods, is an insurance policy against being a poor converter from the precursors found in plant oils. And so Juliet's question is, what tests are available to know whether you're a poor converter? Because in theory, if you're a great converter, you can just eat the plant oils and be done with it. So before I get to the answer to this question, I'll just draw your attention again to, if you haven't bought them already, for $2.99, like half of a fancy Starbucks coffee, I have the Vitamins and Minerals 101 Cliff Notes, and that's at chrismasterjohnphd.com/Cliff Notes. And these, I just released them a couple days ago. These, and I will quote you a section from them in a minute that addresses this question. But this is basically the key points that the most practical, essential points from the last 15 years of my research, all kind of collated into the simplest form I could in a 27-page PDF, and it's just $2.99. And so, buying that is a great way to tip me, and it's also a great way to get like the Chris Master John essentials all in one place. Okay, so here's the background. Essential fatty acids are polyunsaturated fatty acids, which is abbreviated PUFAs, and essential fatty acids can be abbreviated EFAs. And classically, essential fatty acid deficiency, discovered in 1929, and over decades, became more and more apparent that humans get essential fatty acid deficiency. Although generally, so the needs for these essential fatty acids are exceedingly low if you are healthy, sedentary, and in a stable sort of, not changing your weight much, not changing your body mass much, just kind of living as an adult. Needs are very, very low. But for children, for bodybuilders, from people recovering from injury, for women who are pregnant or nursing, for anyone experiencing any kind of stress, that especially stress that involves synthesizing tissue in response to bodybuilding, gaining body mass, getting hurt and recovering, especially if you got to heal a wound, for example. Any deviation from just chilling as an adult will increase your need for essential fatty acids in ways that make this meaningful. And so, and there's also some turnover in the brain, especially So increasingly, we're understanding that the cannabinoid system does use omega-3 fatty acids, but classically, it's we know that it uses arachidonic acid, and the cannabinoids are, um, people are taking CBD oil increasingly to try to impact this system. Uh, THC from weed impacts this system, but it's essential fatty acids that are being turned over in the brain that are mostly impacting the system in a normal, healthy way that leads to things like being calm, facing the world with low levels of anxiety, feeling confident to explore, and things like that. So, classically, we understood essential fatty acid deficiency in the context of a deficiency of omega-6 fatty acids, which led to eczema. But it and this eczema is actually from a defective water barrier in the skin, and so the skin dries out because the water evaporates. But that also means that your skin is less of an effective barrier against toxic things getting in. And so, one of the findings was that, and actually the way it was discovered was some people couldn't reproduce EFA deficiency, and it turned out it was because the humidity was too high in the laboratory. So if the humidity is too high, the water doesn't try to evaporate from your skin. But if the humidity is low in the environment, the water just shoots right out of your skin, evaporates, and your skin dries out, and you get the eczema. But regardless of the humidity, you have a defective skin barrier, and so stuff can get in that shouldn't be getting in. But that also means that that same exact defective barrier functioning is also going to be present in many other places in the body, and most relevantly would be the GI tract. And so if your barrier function is defective in your small intestine, you're going to be absorbing things that you're not supposed to be. That's going to be what people would call leaky gut. And there were also this was especially demonstrated in rats in the experiments. EFA deficiency also causes infertility and all kinds of hormonal problems as well. So that's what we classically understood. And then it became increasingly understood over time, especially after total parenteral nutrition was developed, which TPN is an intravenous system of feeding people. And at first, they had no fats in it, and people developed eczema. And so Ralph Holman, one of the key essential fatty acid researchers of the 20th century, convinced them to start putting fat in it. But the reason they weren't including fat in it is because they found, and actually I have a whole section of in chapter 1, the case for food. I have a whole section on this in my upcoming book. So the reason that they didn't put fat in the TPN was because their experiments with dogs suggested that that the dogs got fatty liver when they put the fat in. So they were like, all right, well, no one's going to be on this stuff for more than a few weeks, so let's just not have fat in it. But when they gave people it with no fat, it turned out that they would develop eczema. And part of this is because these people have like a continuous infusion of glucose into their bloodstream, which stops them from releasing essential fatty acids from their adipose tissue. That's part of why they developed the eczema so easily. So they started putting fat in, but they had two different fats that could be used. One was safflower oil, which has an omega-6 to omega-3 ratio of like 140 or something, and one has and the other one was soybean oil, which is in my opinion, it's not a great oil, but it's much more balanced than a ratio of 140 to 1. And so this girl who had an abdominal gunshot wound and was on this stuff for 6 months before she developed serious neurological problems, but was actually on this for a couple of years. She originally got the soybean oil and she was doing fine. Then she was switched onto the safflower oil and started developing severe neurological problems that included blurry vision, that included tingling and burning that started in her feet, went up the tops of her feet and all the way up to her thighs, and then episodes where she couldn't walk for 10 or 15 minutes at a time. And as soon as they put her back on the soybean oil, everything became normal. So at that point, people said, aha, maybe these omega-3 fatty acids matter. And then that led to decades of research into the importance of DHA, especially in the nervous system. And that includes the retina of the eye. And so DHA is extremely important for basic neurological function. It's important for visual acuity. It's important for learning and so on. So anyway, the gist of this question is, how do you know if you're someone who should be eating DHA from animal foods and arachidonic acid from animal foods rather than just getting something that provides the precursors, linoleic acid? In the case of linoleic acid is the omega-6 precursor to arachidonic acid, and alpha-linolenic acid is the omega-3 precursor to DHA. Why not just have some soybean oil or some flaxseed oil and be done with it? And the answer to this question is, there's not a really there are some genetic SNPs that are known in the fatty acid desaturase enzymes, and a lot of third-party reports with your 23andMe will tell you these, but that doesn't really give you very good information because there's a lot more than just genetics. And I'm not sure all the genetics actually are known, but there's a lot more than just genetics that can give you the problem of poor conversion. And so just to read a section from my Cliff Notes, this is in there's two sections on essential fatty acids, omega-6 and omega-3. And so what it says here is, meeting the target for arachidonic acid is an insurance policy against poor conversion from linoleic acid. Poor conversion can be caused by genetics, diabetes, insulin resistance, inadequate protein, calories, or carbs, inadequate biotin, B6, riboflavin, calcium, or zinc, too much sugar, or consuming reheated vegetable oils. And then finally, a high intake of total PUFA can reduce the conversion, which means that consuming too many omega-3 could hurt the conversion of omega-6. And then under omega-3, it basically says consuming DHA directly is an insurance policy against poor conversion. Factors that hurt the conversion of alpha-linolenic acid to DHA are the exact same factors that hurt the conversion of linoleic acid to arachidonic acid described above. Then it lists all the ones that I just listed. And then the converse of the last point is true here. So a high intake of total PUFA can reduce the conversion, which means that consuming too many omega-6 could hurt the conversion of omega-3. So when you hear things on the internet like you need a ratio of 4-to-1, in generally 4-to-1, between 4-to-1 in favor of omega-6 to 1-to-1, so equal, that really only matters if you're consuming the plant oils, because the issue is that they share the same conversion pathway. So it's both true that they will compete with each other for the pathway, but it's also true that your body perceives the amount of total PUFA that you have basically as like an index, how desaturated are your cell membranes and stuff. It's basically looking at that as an index of how much you need the enzyme. So the more total PUFA you have, the more it starts turning down the regulated enzymes in that pathway. And so I think it's interesting to know if you have a fatty acid desaturase SNP in your genetics, but given all these factors, more than a dozen factors that can lead to poor conversion, I don't think it makes any sense to assume that you are or are not a good converter or a bad converter based on your genetics alone. So to go back to Juliet's question, what are the available tests to know whether you're a poor converter? Basically, anything that will look at the ratio of the precursors found mainly in the plant oils to the animal form will help give you an answer to that. However, that's going to be somewhat limited. A caveat to that test, to the interpretation of that test, is going to be, it may look like you're an okay converter if you're not consuming plant oils and you are consuming the animal foods. So, you have to use this information in the context of the diet you were eating when you got the test. So let's say you have, the best way to know how good of a converter you are is to be a vegan and not take any supplements with algal oil DHA or with fungus-derived arachidonic acid. That's how you'd get the best knowledge of your conversion, because then you're not consuming the end products of the pathway. You're only consuming the precursors, and you can look at what end products are showing up in your blood. Now, you can get fatty acid profiles from, I know you can get it from Quest. Not You can probably get it from LabCorp. There's fatty acid profiles in the Genova ION panel, and but I think the best test is the complete version, which is the most expensive option of OmegaQuant. And I haven't worked much with OmegaQuant, so I'm not too familiar with it. But the principle of it is that they're looking at the phospholipids in your cells, and I think that's and this is confirmed by research studies, that's a better index than the plasma values, which are the circulating fatty acids that are not in your cells. And so, even though I don't have much experience with OmegaQuant, I I am happy saying that they offer the best commercial test. But you would have to get their complete version in order to get a full fatty acid profile, which is their most expensive option. Now, one thing I do like about the Genova ION panel, even though it's measuring them in plasma, is that it does report and give a range for the LA to DGLA ratio. And that's in a Genova ION panel plus 40 amino acids, that would be line 35. And they give a range for that, which is, the range is based on what's in their normal population. I believe that they took that based on just everyone who was submitting Genova ION profiles and looked at the distribution. And so if you're out of that range, I think it just means you're sort of like more than 2 standard deviations away from the normal for the people submitting those profiles. So it's not, the range isn't perfect, like it's a range associated with health endpoints, but it gives you a sense of whether you're a good converter. So DGLA is an intermediate in the pathway. But to be honest, the way that I would really look at this is you want your arachidonic acid and your DHA to be at least in the middle of the range, preferably towards the top of the normal range, both of them. And that is going to make sure that you get the neurological benefits of the DHA, that you get the immune function and barrier function benefits of arachidonic acid, and also the neurological benefits. And it's going to offer some insurance policy that if you go into a condition of oxidative stress or into a condition that you were not in before that requires recovery from tissue injury, or you start bodybuilding, or you become pregnant, that, being on the higher end of the range basically gives you some reserve capacity to start depleting those fatty acids. And so, if you're trying to eat a mixed diet that is healthy, you're going to already have arachidonic acid and DHA in your diet. Arachidonic acid from liver and egg yolks, DHA from fish or fish liver oil or what have you, maybe pastured egg yolks. Or if you don't have those in your diet, vegan or not, you might be supplementing with fungus-derived arachidonic acid or algal oil for DHA. And under those circumstances, you're not going to get pure information from looking at these ratios about whether you are a good converter or not, because you're not relying totally on conversion of plant oils. But you can get good information on whether you are on the higher end of the range of those two fatty acids. And I would be more interested in that personally, right? Because unless I'm relying exclusively on plant oils, I don't really care whether I'm a good converter or not. It'd be nice to know, but it doesn't actually matter if I'm consuming the end products of that pathway. And so that's what I really care about, being on the upper end of the range for both those fatty acids. Now, if you're not on the upper end of the range and you're, even if it doesn't report a ratio, you can look at, well, am I on the low end of the range for arachidonic acid, but on the high end of the range for linoleic acid? Am I on the low end of the range for DHA, but on the high end of the range for alpha-linolenic acid? Regardless of your diet, if you're on the opposite ends of those ranges in a way that favors high ends of the precursor and low ends of the end product, then I think that's a pretty good way to know that you're probably a poor converter. But, what are you going to do about that? Are you going to fix what's making you a poor converter, or are you going to consume the end products of the pathway? And so to me, I'll just read that section from my Cliff Notes again. The factors that hurt the conversion are genetics, diabetes, insulin resistance, inadequate protein, calories, or carbs, inadequate biotin, B6, riboflavin, calcium, or zinc, too much sugar, presence of reheated vegetable oils, or too much PUFA, or an imbalance between omega-6 and omega-3. So are you going to go down the list and check off each box to figure out what's making you a poor converter? And then, maybe arrive at it's your genetics and you can't do anything about it after a year of trying to figure it out. Or are you going to just consume some DHA and consume some arachidonic acid? So the way that I look at that is, and again, I'll read the sentence right before that paragraph on the factor says, bullet point, consuming DHA directly is an insurance policy against poor conversion. Bullet point in the other section, consuming arachidonic acid directly is an insurance policy against poor conversion. That insurance policy is so radically simpler than figuring out whether you're a poor converter and why, that I would just do that. With that said, the answer to Juliet's question is any test that has a full fatty acid profile, preferably in a phospholipid such as OmegaQuant, but it could be in plasma such as Genova ION panel, LabCorp, I think, Quest. Just look at whether you are in the higher end of the range for the precursors, which omega-6 is linoleic acid and omega-3 is alpha-linolenic acid, and in the lower end of the range for the end products, which for omega-6, the key one is arachidonic acid, omega-3, the key one is DHA. If they report a ratio, fine, but you can just look at the relative position of the end products and the precursors and the ranges. If you're accumulating the precursor and you're not getting the end product, then you probably are a poor converter. But what would I be focusing on? I wouldn't be focusing on the conversion. I would be focusing on whether you have enough of arachidonic acid and DHA. I'd at least want to be in the middle of the range, but I prefer to be on the higher end of the range for reserve capacity, because you never know what's going to change about your situation that's going to take you from the top of the range to the middle of the range. And if you're on the middle of the range or the lower end of the range, then whatever that would be would take you outside the range into the area of deficiency. So I think it's better to be on the higher end. I'll just look at the live chat just to see if there's any highly relevant things on. Yeah, well, so Luke says, I started having dry cracking soles of feet. Is this from EFA deficiency, B vitamins, B3? I don't know. That is something that could be from EFA deficiency, but dry cracking skin can be from humidity, can be what you're putting your skin through. Obviously, in the soles of your feet undergo a lot of stress from walking. You can get, feet are very vulnerable to fungal infections, especially when you have sweat accumulating in your socks. And then, even these EFAs, right? Recall the factors that affect conversion. There's a lot of B vitamins there. And so a deficiency of any of those B vitamins can be relevant by affecting the process of conversion. But again, you just want to get the end products up. And so, if it's B vitamins affecting conversion, then, getting the end products in should help. But it could be so many things. So it's very hard to deal with that. Mike makes a point to Luke, says you can try evening primrose oil. Yeah, so evening primrose oil and borage oil have intermediates in the pathway that are after linoleic acid, but before arachidonic acid. You could also try, get arachidonic acid, try it topically and stuff like that as well. Matt Blackburn says they're not essential though. Yes, they are. I know Ray Pete stuff. I was selling a report before how essential are the essential fatty acids. You can't get it anywhere anymore. So maybe I should start giving that away for free or something like that. But check out my article on the Weston A. Price site, Precious Yet Perilous, that does address the evidence on why they are essential. All right, that's it for today. Hope you enjoyed this, and I'll try to do this again tomorrow. Take care, guys. Don't forget to like the video, share it if it's shareable, and subscribe. And then again, Cliff Notes are last 15 years of my work in bullet point form for each essential mineral, vitamin, and fatty acid in a 27-page PDF for half of a fancy cup of coffee. So head on to chrismasterjohnphd.com/cliffnotes. Thanks, guys.